Hello everybody, welcome to the algorithm course. In this video, I'm going to discuss the meta-binary search process. In general, there are 5 major processes. First, I would like to find out the largest index allowed for a sorted array. And then I would like to find the number of bits that is used to represent the largest possible index. And then I'm going to determine the bits starting from the most significant bit of the undetermined portion. And I will assume that the MSB, which is the most significant bit, is 1. And then I will repeat the filling of the bits that try to represent the index of the target element until all the bits are filled in. And this part will be elaborated in detail in the next slide. Finally, I can check whether the resulting index would point to the target or not. If it really points to the target, then I would say that the target is found. Otherwise, the target is not found. Here I would like to elaborate on the way to determine the bits of the index. First, I assume that the most significant bit is 1. And then I would assume the remaining bits in the undetermined portion are all zeros to get a temporary index. If the element of this temporary index equals the target, then the target is found at this temporary index, and this index is just our target index. Else, if the index is larger than the largest index allowed, then we would change that MSB, or the most significant bit of the undetermined portion, back to 0. In this case, the MSB is now set. Else, if the element of this index is larger than the target, then we change that most significant bit of the undetermined portion back to 0. And of course, the MSB is now set in this way. Else, if the element of this index is actually smaller than the target, then we just keep this most significant bit of the undetermined portion as 1. And in this case, of course, the MSB is also set as 1. Now let us see this example. Suppose I have a number of sorted numbers, and our target is 11, which is inside the array. Now we have a length of 12 from this array, and of course the maximum index allowed is 11 if we start the index with 0. And for 11, we need 4 bits to represent this index because the largest index allowed is 1011 in binary digits. Now, we want to find out the bits corresponding to the target index. In the first step, we have to say that all the 4 bits of the index are undetermined. That's why I have 4 spaces. The first question is like this. Can the MSB be 1 so that the bits will start with 1 and the other 3 bits are undetermined? To answer this question, we have to assume that the remaining bits in the undetermined portions are all zeros. For this case, we have an index of 1 at the beginning, and if I fill in the remaining bits as 0, then the smallest index is actually 1000, which corresponds to 8 in decimal numbers. And when I put this index into the array, I would find that index 8 would correspond to 23, which is actually a number larger than 11, which is our target. In this situation, the element of the smallest index allowed is larger than the target. And in this case, the most significant bit cannot be 1. I have to change it back to 0. So the bit pattern is like this. The first bit is determined as 0 already, and the remaining 3 bits are yet to be determined. Now we continue the filling in action of the bits. When the bit pattern is already 0 at the beginning, it actually means that we have limited the range from 0000 to 0111. And in decimal numbers, the resulting index range would be just from 0 to 7. If I want to fix the index range in this way, the right portion of the unchecked array is ignored. That's why I have covered those elements to be ignored with a different color. And we have already filled in the first bit of our target index. Now we try to fill in the second bit. can the MSB of the undetermined portion be 1, so that the bits are 0, 1, and we have 2 bits undetermined? Now let's take a look in this situation. We have to assume that the remaining bits in the undetermined portions are all zeros. For our case, with 0, 1 as the beginning, the smallest index allowed is 0, 1, 0, 0, which is reading 4 in decimal number. So when I put this index into the array 4 equals 0, which is less than our target, which is 11. The element of the smallest index is actually smaller than the target. In this case, we can keep the most significant bit as 1. So we have determined the first 2 bits of the target index as 0 and 1 respectively. Here we have 2 bits yet to be determined. When the bit pattern is already shown as 0, 1 together with 2 undetermined bits, we actually limit the range from 0, 1, 0, 0 to 0, 1, 1, 1. That means the resulting index would range from 4 to 7. If we have this range, it means that the left portion of the unchecked array is ignored. That's why I also shade elements with index 0 to index 3. Now let us try to fill in the third bit. Can the most significant bit be 1, which corresponds to the most significant bit of the undetermined portion, so that we have 0, 1, 1 as the first 3 bits and we have only 1 bit to be determined? Now we can assume that the remaining bits in the undetermined portion are 0. Since we have only 1 bit to be determined right now, we can see that the smallest index allowed is 0, 1, 1, 0, which means 6 in decimal number. Index 6 corresponds to number 15, which is actually larger than our target of 11. The element of the smallest index is actually larger than the target. Then the most significant bit cannot be 1. We have to change it back to 0. That's why the bit pattern is determined as 0, 1, and 0 for the first 3 bits, and we have only 1 bit yet to be determined. Now when the bit pattern is already given by 0, 1, 0 together with an undetermined bit, we actually limit the range from 0, 1, 0, 0 to 0, 1, 0, 1. It means that the resulting index range would be just from 4 to 5. In this case, the right portion of the unchecked array is ignored. That's why I also shade index 6 and index 7. Now we have only 1 bit remaining to be filled. Can this bit be 1, so that we have the bits as 0, 1, 0, 1? Now we have to assume the remaining bits in the undetermined portion to be 0 again. But we have already filled in all the bits with the temporary value of 1, so we have no way to fill in further zeros into this temporary index. Now the smallest index is 0, 1, 0, 1, which is 5, and index 5 would correspond to 11, which is actually our target. And now of course all the bits are already filled in, and the bit pattern is already determined as 0, 1, 0, 1. And of course the target is now found at index 5, which means that our search is now complete, and we have really found the target in the array. Let's see another situation that the target cannot be found. So now I use the same array, which is already sorted, and the target is now 25. Of course, the length of this array is still 12. That means the maximum index is still 11. We have to use 4 bits to represent this index because the largest index allowed for this array is 1011 in binary digits. In the first step, all the 4 bits of the index, which is the target index, are all undetermined yet. So can the first bit, which is the most significant bit of the undetermined portion, be 1, so that the bit will start with 1 together with 3 undetermined bits? The first step is to assume that the remaining bits in the undetermined portion are all zeros. So for my current case with 1 at the beginning, the smallest index is 1000, which means 8 in my case. Index 8 in the array would correspond to 23, which is actually smaller than our target of 25. the element of the smallest index is actually smaller than the target. It means that the most significant bit can be 1. In this case, we have already set up the bit pattern as 1 together with 3 undetermined bits. When we have already got the first bit as 1, we actually limit the range of the target index from 1000 to 1111. It means that the resulting index range would be from 8 to 15. However, in practice, the range is only from 8 to 11, as the largest index allowed is 11 only rather than 15. So it means that the left portion of the unchecked array is ignored. That's why I shade index 0 up to index 7. Now that we have already determined the first bit, how about the second bit? Can the second bit, which is now the most significant bit of the undetermined portion, be 1, so that I have 2 1s at the beginning? We have to do the step again. Assume that the remaining bits in the undetermined portion are all zeros. For our current case here, the smallest index is 1100, which means 12 in decimal number. And of course, index 12 is out of our allowed range because our maximum index can only be 11. It means that the most significant bit cannot be set as 1. We have to change it back to 0. So we have the bit pattern as 10 for the first 2 digits, and we have 2 more digits to be determined. When the bit pattern has 1 and 0 respectively, we actually limit the range from 1000 to 1011. The resulting index range would be from 8 to 11. It means that the entire unchecked array is still retained. Now we go to determine the next bit. Can the most significant bit be 1, so that I have the bit pattern as 101 followed by 1 more undetermined bit? We have to go through this step again. Assume that the remaining bits in the undetermined portion are all zeros. For 101 and an extra undetermined bit, the smallest index is 1010, which means 10 in decimal number. Index 10 in the array corresponds to 32, which is actually larger than our target of 25. The element of the smallest index is actually larger than the target. The most significant bit cannot be 1. We have to change it back to 0. So the third bit would be 0, and we have the bit pattern as 100 followed by 1 more undetermined bit. Actually, when the bit pattern is 100 followed by 1 more undetermined bit, we limit the range from 1000 to 1001. It means that the resulting index range is from 8 to 9. It means that the right portion of the unchecked array is ignored. That's why I shade elements with indices 10 and 11. Now let us see the final bit. Can the final bit, which is the most significant bit of the undetermined portion, be 1, so that the bits are 1001? Now we have to go through the step again. Assume that the remaining bits in the undetermined portion are all zeros. Since we have already filled in all the bits, we have no way to fill in further zeros. So we just check 1001. For this index, the smallest index is just 1001, which means 9 in decimal number. Index 9 corresponds to number 29, which is of course larger than our target of 25. Now we have this situation. The element of the smallest index is actually larger than the target. In this case, the most significant bit cannot be 1. We have to change it back to 0. It means that the bit pattern is 1000. Now we see that the bit pattern is determined as 1000. All the bits are already filled in. The corresponding index is 8 in decimal number, and index 8 would refer to 23, which is actually not equal to 25, but it is smaller than 25. The target cannot be found at index 8 even though all the bits are already determined. So we are sure to say that the search is complete without finding out our target from the array. Thank you for walking through the algorithm with me. If you have any questions about my video, please leave your questions at the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.